This is Chapter 3, Weight-Volume Relationships, Extra Example 2. For this example, we're going to derive weight-volume relationships using the phase diagram. And there are two parts to this problem. And for part A, we're given the void ratio E, the specific gravity GS. We're going to look for the dry unit weight gamma D. Since everything here is given in terms of ratios, we can safely assume either volume solids or total volume being 1. And whenever you see void ratio is given, it is more convenient to assume Vs being 1. So let's put the volume solids, Vs equals 1 on the phase diagram on the volume side. And the void ratio E, by definition, is volume of void, V sub V, over volume of solids, V sub S. From this expression, you can calculate volume of the void is E times Vs, and Vs is assumed to be 1, so the volume of void is simply the same as void ratio. So that's why whenever you see void ratio is given, it's more convenient to assume Vs equals 1. So let's put V sub V equals E on the phase diagram. So we have basically the volume side completed. And to get the weight side, we'll start with specific gravity, which is gamma S, unit weight of solids, over gamma water, unit weight of water. And gamma S is weight of solids over volume solids. And from this, you can calculate Ws, that's a weight of solids, equals GS times Vs times gamma water. And Vs is assumed to be 1, so Ws is GS times gamma water. And you can put this on the weight side. That's the weight of solids. That's basically all the information we need to calculate gamma D. So your dry unit weight is weight of solids over total volume. And from your completed phase diagram, you have the weight of solids and the total volume expressed in terms of the given void ratio E and the specific gravity GS. So that's basically the final expression you're looking for dry unit weight. Next, we're going to look at part B of this example, where void ratio is the unknown. And for part B, the known quantities are the dry unit weight gamma D and specific gravity GS, and we're looking for void ratio E. We're going to use the same phase diagram. We have the weight and volume side. And similar to part A, we only need to know the volume of the void, and then we have the solid phase as well. And similar to part A, we are given everything in terms of ratios, so we can assume volume. And for this part B, because gamma D is given, which is weight of solids over total volume, so it's actually more convenient to assume total volume V is 1. So we're going to put V equals 1 on the phase diagram. And as you can see from the definition of dry unit weight, if we assume total volume V is 1, then the weight of solids is gamma D times V, which is basically gamma D, because total volume V is assumed to be 1. So we can put the weight of solid Ws on the phase diagram, which is the same as gamma D for this example. And once we have the weight of solid, we know the specific gravity GS, which is the ratio of gamma S, unit weight of solid, over unit weight of water, gamma W. And unit weight of solid is Ws over Vs. And from this, we can calculate volume of solid, which is Ws over GS times gamma water. And if you plug in gamma D for solid weight of solid, you get an expression for volume of solids. And we can put this on the phase diagram, gamma D over GS times gamma water. So that's the volume of solid. Once we have this volume of solids, then the volume of the void is total volume V, which is 1 by our assumption, minus volume of solids. So it's 1 minus gamma D GS gamma water. So now we have the volume for both voids and the solids. The void ratio by definition is volume of void V sub V over V sub S. And we have V sub V and V sub S on the phase diagram. Just substitute these two expressions and simplify. You get a final expression for the void ratio E, which is basically GS gamma W over gamma D minus 1.